Okay, the next type of distribution is something called a triangular distribution. In this case, the density curve will be given to you by a function, and the function will typically be written in some form like this. F of x is equal to, and there will be a functional expression where the PDF is greater than 0, and it tells you where it's greater than 0. And then it will also tell you that anywhere else it is 0. So what this function is telling you, or what you can calculate from this function, is the height of the density curve at any value of x. Okay, so this curve that we're working with right here, you'll notice that for these triangular distributions, the function is going to be a linear function. Okay, notice we've got the slope of negative 2/9 in this case, and the intercept is 2/3. So we can see our triangle here. Remember, it says that the base, the domain goes from 0 to 3, so that's what we've got right here is 0 to 3. The intercept when x is 0 is 2/3, and that's what our height is. If you plug 3 in, what we get is 2/3. Let's put this up here. We get 2/3 minus what is effectively 6/9. 6/9 is 2/3, so 2/3 minus 2/3 is 0. And so we end up getting a triangle. Okay. Now, I'm sure some of you remember, the area of a triangle is equal to 1/2 the base times the height. So with any of these triangular distributions, we're going to be using the area of a triangle to calculate the probability. Okay, so in our first case here, we're looking at the probability that x is greater than or equal to 1.7. So as you can see here, I've sketched the drawing, filled it in at 1.7, and since we're looking at greater than or equal to, what we're looking at is the part to the right there of 1.7. As you can see, that is also triangular in shape. Okay, so we need to get the height. We're going to get the height by plugging 1.7 back into our function up at the top. I've written it right here. So we've got 2/3 minus 2/9 times 1.7. If you calculate that out as a fraction, it works out to be 26/90, or if you put in a decimal, it's actually 0.288. Where the 8 repeats are 0.2889 to 4 decimal places. Okay, so that's our height. The length of the interval, we're going from 1.7 to 3, so that's 1.3. So our probability is 1/2 times the length of 1.3 times the height of 0.2889, and that gives us 0.187785. So that's our probability associated with that. Oops. Okay, that was a quick zoom there. Now, the next one here, probability that x is less than or equal to 1. Okay, well, again, I've drawn the picture here, and you'll notice that in the process of drawing this picture, we don't have a triangle for the shaded region, but the unshaded region is a triangle, and so we can do this by using the complement rule. So what we're going to do is we're going to get the area of the triangle that's the part of the triangle that's not shaded, and we're going to subtract that from 1. Okay, our line here is at 1, and so the height that we need there, we're going to plug 1 into our expression up at the top again. So that 2/3 minus 2/9 works out to be 4/9. Sometimes I have to peek around here. And so the probability that x is greater than 1, we'll plug that in. 1/2 again times the length. The interval that we're working with goes from 1 to 3, so the length is 2, times the height, which is 4/9, and that works out to be 4/9. So the probability that x is less than or equal to 1 is 1 minus that. 1 minus 4/9 is 5/9. Okay, same one here. In terms of the triangle, we're looking at the probability that x is between 1.2 and 2.4. Hang on a second, I'll be right back.